हेलो, हाय एवरीवन, गुड आफ्टरनून. कैसे हो सब लोग? ऑल गुड? तो अभी तो एग्जाम स्टार्ट हो गई ना सबकी. पहला पेपर हो गया या फर्स्ट पेपर इज देयर? आई थिंक इंग्लिश है ना फर्स्ट पेपर ऑन मंडे. ओके, ऑल राइट. सो चलो फटाफट हाय हेलो बोलो. आई वांट टू सी हु इज देयर. Great. Hi Akshaya, sorry. Study player. Pathania, hi. Good afternoon everyone. Anushta. Okay, Jay. Good afternoon. Monday is the first exam, right? So you prepared, you guys? पढ़ाई हो गई सबकी? Hello Krishiv. Good evening. Good afternoon. I have that habit, right? Saying good evening. Okay. All right. So today we are going to do one shot physics. पूरा grade 10 का physics हम one shot में पढ़ेंगे. Within let's say 1.5 hours. देखते हैं, है ना? Hi Dhanu. Good afternoon. Indresh, good afternoon. Brijesh, Baijit. Okay, Instagram Reels, nice. Triangular round, facts. Free Alok, Vishnu, Aryan. Great everyone. Today it was Marathi paper, nice. Oh, I am also from Maharashtra. I also had like first language as Marathi, then second language Sanskrit, and third language was English. Okay everyone, great. Depressed, why you're depressed? Don't be depressed. Book mechanics, oh you guys are very creative. Nice names. Okay, great. So let's begin. This is a one shot, so I'll not spend so much time on things which are not important. Let's focus on the things which are important. So the first one, important and bit difficult for you guys. Sign convention for the mirror and lens. So we know there are two mirrors, that is this one is concave, there is a pole, then we have focus and center of curvature, then we have convex mirror. So convex, there is a pole, focus and center of curvature. Then we have two lenses, one is concave lens, so this is optical center. We have here f1, f2, there is 2f1 and 2f2. Then we have convex lens, optical center, f1, 2f1, f2 and 2f2. So what is sign convention? So just divide everything as if there is a Cartesian book or Cartesian plane. So this is the origin. This is the origin. Here you divide the lens into two parts. So optical center will become the origin. This is the origin. So these are the four different graphs. So now, for example, when you divide it into four different graphs, so this is the x prime and this is y prime, correct? So now when you go to the right, if you measure anything on the right, that would be positive. If you measure anything on the left, it is negative. All the measurements should happen from the origin. So when you have lens, we measure everything from the optical center. If you have the mirror, measure all the distances from the pole. Okay. Now if you go above, up would be positive, down would be negative. So what do you measure on the x-axis? X-axis में हम क्या measure करते हैं? तो दो चीजें x-axis, तीन चीजें measure कर सकते हैं. First is the object distance. So for all of them, object is somewhere here. There is the object, right? So u is going to be negative. Why? क्योंकि हम P से we are measuring towards left. So for all of them, u, which is the object distance, is always negative. How v? So v, if the image is forming on the other side, it is going to be positive. If it is forming on the same side, it is negative. Okay? English बहुत tough आएगा. Okay. Then what do you measure above? So this x prime is the principal axis for all of them, right? When you go above, that is the height. We measure either above or below. So when you measure it above, for example, this object here, we are measuring above. So that would be positive. When you measure it below from the principal axis, it is going to be negative. So that is the sign convention. And I am sure lot of you will do lot of mistakes regarding the sign convention. But if you do it correctly, then there is nothing in this chapter. This chapter is very easy. Most important thing, sign convention. You will definitely do some mistake and lose some marks. Okay, so फटाफट जल्दी बताओ मुझे, for these four we have four focal length. So for which the focal length is positive and for which the focal length is going to be negative? फटाफट tell me in the comments. Okay, I'll write down here. These are the four objects. A, which is the concave mirror. B, there is a convex mirror. C, concave lens. And D, convex lens. So for which focal length is positive? Physics is easy. Nice. Okay, hi, sorry, I forgot Ishita Mahajan. Hi Ishita. Yeah, question is, for which of the four focal length is positive? Concave, negative, convex, positive. Yes. So that is a very simple rule. How do you know for which focal length is positive? Convex. So which are convex? This is convex, this is convex. So here what will happen? This is the focus, correct? Here if the rays parallel to principal axis, they will converge at the focus. So this is the focal length. Here the rays, they will diverge and they appear to diverge from the focus. So in this also focal length is positive. Focal length positive. For concave, for both of the concave mirror and concave lens, focal length is negative. Why? These rays which are parallel to principal axis, they converge here. So this is the focus. Focal length is on the left. So focal length here is negative. Even for this, rays, they will diverge, something like this. Correct? They appear to diverge from the focus. So we measure the focal length on the left. So even for this, focal length is negative. Do this correctly and there is nothing very like crazier in this chapter. This chapter is very easy. Okay? One more thing you need to remember, the mirror formula and the lens equation. So फटाफट बताओ मुझे, what is the mirror formula, what is lens equation, and what are the magnification for both of them? Tell me for which there is a positive sign, for which there is a negative sign. Write down in the chat फटाफट. Mirror formula. I'll write the first one, you tell me the rest. Then lens equation. And then magnification of both of them. Magnification for mirrors, magnification for the lens. Yes. So for the mirror formula, is it going to be plus here or minus? For mirror, this is going to be plus. 1 by V plus 1 by U is 1 by F. F is the focal length, U is the object distance, V is the image distance. Here we have negative sign, 1 by V minus 1 by U is 1 by F. Okay, that is the lens equation. This is the mirror formula. And what is the magnification? So magnification, we know height of the image divided by height of the object for both of them. Height of the image divided by height of the object. But now there is a V by U. Magnification is V by U. So for which magnification is positive? For which magnification is negative? So magnification is positive. Here there is a plus sign, V by U. And here we have the magnification which is minus, sorry, there is opposite. See, even I am making mistakes. Here we have negative minus V by U, this plus V by U. Correct? How do you know whether you have written the correct sign for the magnification? Just remember one case. We have, let's suppose, the convex mirror. If you place an object, there is an object, image will form between pole and the focus. So this is the image. So is the magnification positive or negative? For this, both height of the object and height of the image, both of them are positive. Correct? But this U and this is the V. So U is negative, V is positive. So this is what it would be. V is what? V is positive. This is divided by, what is U? U is negative. U is negative. And this is multiplied by, there is a minus sign. Correct? So this minus minus will cancel out. So that is how the magnification would be positive. So there is a negative sign for the mirror and positive sign for the lens. Clear? Easy as up? Okay, chalo, let's solve some questions now. Let's solve the question. So what is the question? Consider the diagram in which M is the mirror. Okay, there is a diagram. This M is the mirror. Hi Kushal Sinha. Good afternoon. P is the object. So this is the object, this one. There is some mirror. They have not said which mirror. And what is this Q? Q is the image. So this is what kind of image? It is enlarged image. So which mirror can create enlarged image? Can you tell me? So first mention the type of the mirror. So what mirror is this? Is it a concave mirror or a convex mirror? So what kind of image is this? This image is forming on the behind the mirror. So there is a behind the mirror, image behind. So that is virtual and erect. This image, and it is also enlarged. Virtual and erect and enlarged. So what type of mirror it should be? Which mirror forms? Correct, Farish. Nice. So this is a concave mirror. Concave mirror can form enlarged image. So the what type of mirror is this? There is a concave mirror. Okay. And characteristic properties of this image. So it is forming behind the mirror. It is virtual, erect and enlarged. So these are the properties of the image. Clear? Easy? So these are called as, like, they will give you some question which is not from your NCERT. These are like a competency based questions. So don't worry, they are very easy. I will tell you how easy are they. Held for review. Okay, you are not typing something correct. Okay, let's next topic, that is the power of lens. Here, what mistake you do? Tell me, can somebody tell me? In the power of a lens, the equation is very simple. I will write down the equation. Power of a lens P is 1 by focal length. F is the focal length of the lens. It can be concave or convex. But one mistake that lot of you do, and that is you write down the focal length in centimeters. which is incorrect. So this focal length should be in meters. Meter is the SI unit of distance. Focal length is distance, correct? So it should be in meters. When you substitute the correct value, then you get the power, the SI unit of power as diopter. Diopter is the SI unit of power. No, you generally don't do a mistake of the sign convention here, but sometimes the focal length is given in centimeter and you are in a hurry of solving questions and you do the mistake. So make sure that the focal length should be in meters. That is the most important. Okay. So now next question. There is not MCQ, there is a just question. So determine the focal length of a concave mirror. So 3 students. Oh yeah, there is a MCQ. All right. There are 3 students A, B, C focused a distance building on a screen. Okay, we have a which mirror? Concave mirror. So they measure the distances as given below. So I'll draw the image. For example, there is a distant building. So there is a building, for example, which is our object. Then we have what type of mirror? Concave mirror. So this is a concave mirror, correct? So there is a very far distant building. That means an object which is very far, right? So this I can say the object is somewhere like infinity. Something which is very far, you can say that it is at infinity. So what will happen to this? The rays, incident rays would be parallel to principal axis, right? And they will converge at principal focus. So these are the reflected rays. They converge at the focus. So now let's read what distance is measured. So student A is measuring the distance from the mirror to the screen. So at this position there is a screen here. There is a screen. So student A measure the distance from the mirror to screen. This is a A. Okay. You have a doubt? Yes, Dhruv, what is your doubt? Now the second student from building to screen. So student B is measuring this distance. And student C from building to the mirror. So he is measuring from the building to the mirror. There is a distance measured. Read the question wrong. Okay. So now what is the question? They measure the distance as given below. And what is the question? So who measured the focal length correctly? So out of these 3, who measured the focal length correctly? So what is focal length? It is the distance from the focus to the mirror, correct? This is our screen. So it is this distance measured by A. So which one is correct? Only A. The distance measured by student A, that is the correct measure of the focal length. Okay, yes Farish, correct. Vishnu, nice. Kushal, yeah, some of you gave correct answers. Depressed water is giving correct answer, nice. Understood? Okay Dhruv, great. Yes Anshuka, sorry I am very sorry at your name. Anushta, okay Anushta, okay. Great, let's go to the next question or next concept. What do we have? So we have Snails Law. So where do you see Snails Law? Snails Law we see when there is change in the medium, right? This is medium 1, this is medium 2, and the ray of light is incident at an angle. So what? So let's suppose there is a normal, there is an angle between the incident ray and the normal. This we call it as angle of incident. So what should be the maximum and the minimum value of angle of incidence? Can you tell me? Yes. What is the maximum and minimum value of the angle of incidence for the Snails law? Somebody tell me. Okay, now I am giving you another case. This is a optically rarer medium and this one is optically denser medium. This is a optical density, okay? Optical density, not the actual density. So what will happen here? There is a optical density, so ray will bend and it will, when it goes from the rarer to denser, it will bend towards the normal. So something like this. So there is a refracted ray. There is an incident ray and the refracted ray. So this is called as angle of refraction. Correct? So now I told you one question. What is the minimum and maximum value of I for the Snails law? So the minimum value is 0 and the maximum value is 90. So can you tell me why the minimum angle is 0 or should be greater than 0? If let's say the angle of incidence is 0, will there be any bending of light? Rarer angle is low. No, that is not correct. In the denser medium, the angle is smaller. In the rarer medium, angle is larger. Okay, so if, I'll tell you, if angle of incidence I is 0 degree, then what will happen? So it is something like angle of incidence is along the, I'll use another color. Just a minute. So this is our normal. So the incident ray would be along the normal. There is an incident ray. So this incident ray will not bend. There is no bending. It will pass as it is. So the angle of refraction will also be 0 degree. Correct? So now what is Snails law? Snails law says that the relative refractive index of medium 2 with respect to medium 1, refractive index of the second medium with respect to the first medium is nothing but sine of angle of incidence to the sine of angle of refraction. Correct? So now if both the angles are 0, what will be this ratio for here? So sine 0 divided by sine 0, that would be just 0 divided by 0, which is not defined. Correct? So when the angle of incidence is 0 degrees, we cannot use the Snails law. And if the angle of incidence is 90, so how will it look like? So it will look like something like, let's suppose there is a medium. So this is a grazing angle. There is an incident ray. So if this angle of incidence is 90, this ray will not go into the second medium. It will just pass as it is. It will not go to the second medium. So there is no bending, no refraction. So again for this case, we cannot use the Snails law. So that is the reason angle of incidence is between 0 and 90 degree. Clear? Okay, so now, do you know what is the absolute and the relative refractive index? How the absolute refractive index is defined as? So the refractive index of any material is defined as C divided by V. What is C? C is the speed of light in vacuum, that is 3 into 10 raised to 8 meter per second. Yes, there is a speed of light in vacuum which is the fastest speed, and V would be speed of light in that particular medium and is the refractive index. So let's suppose I'll give you two medium, N for water is 1.3 and N for diamond is 2.4. So in which medium light will travel faster, water or diamond? In which medium light will travel faster? So the speed is, you see this relationship here, c is a constant. So from here we can say v is inversely proportional to n, right? So speed of light in water is inversely proportional to 1.33, and here the speed of light would be, speed of light in diamond is inversely proportional to 1.24. There is some constant here. So because the refractive index of the diamond is greater, the speed would be slower, correct? Clear? So this is the refractive index. So now there is the absolute refractive index. So now what is the relative refractive index? Let's suppose n to 1. This is the relative refractive index of medium 2 with respect to medium 1. It is defined as n2 divided by n1. n2 and n1, these are the absolute refractive indices. So now what is n2? I can write it as c divided by v2. What is n1? c divided by v1. Okay. So this is nothing but, you can cancel the c from numerator and denominator. So what is left? It is 1 by v2 divided by 1 by v1. So if you rearrange the terms, it will come out to be v1 divided by v2. This is n to 1, correct? And now it is v1 divided by v2, not the other way. Okay, Vishnu? You remember Snails law? We have sin I by sin R. So you can combine here. So this is sin I by sin R. So this is the absolute refractive index. This from the definition and this is from the Snails law. Clear? Yes. So now we have a question. So question is given as refractive index of diamond is 2.42. So what is the meaning of this statement? Hello Milan. Hi Princey Jaiswal, good afternoon. Squad killers, good afternoon. Okay. So what is the meaning of refractive index? Refractive index n means speed of light in vacuum divided by speed of light in that particular medium. So if refractive index is 2.42, so if I write this as 2.42, that means the speed of light in diamond will be c divided by 2.42. This is the speed of light in the diamond as a medium. Okay. So you can substitute value of c, which is 3 into 10 raised to 8 is meter per second divided by 2.42. So the speed of light in diamond is slower than the speed of light in vacuum. That is the meaning of refractive index. Clear? Light, yes, correct. That's what it means. It moves 2.42 times slower than the speed in vacuum. Correct. Sahin. Nice. So now the next topic. Light chapter is over. See, very simple, right? Very easy. Complete topic. So in the next chapter, that is the human eye and colorful world. So there are three major subtopics. First is the human eye, then we have the prism, and then we have atmospheric refraction. So let's do the first one. So there is a human eye. The working principle is very easy. You have learned in 8th. So they will not ask any questions, major questions on the working principle. I'll quickly tell you. We have first cornea. It is this cornea here. And what is the purpose of the cornea? Bends or refracts most of the light. Then pupil. So this black region here is the pupil. And then we have here, I'll draw it again. So this region here, this is a cornea, correct? This is a cornea. Then we have the lens. Which one is the lens? This blue color, that is the lens. Then retina. Which is the retina? Here you see the screen, this is the retina, where the image is going to form. Then optical nerve. So okay, let's do the working. Cornea bends most of the light. Then we have pupil. What does it do? What does pupil do? Apparent depth, it is not there in your syllabus. It is very simple. Okay, just give me a minute. I'll tell you about the apparent depth. Pupil allows the light to go inside. Pupil is like a door. When you open the door, light will come inside the eye. Then we have the lens. Lens does not refract the light. What lens does? It focuses the light. So light can be coming from a distant object or from the object which is nearby. For example, your mobile phone or book. So that focus of the different light is done by the lens. Then we have the retina, that is just like a screen on which the image is formed. Then optical nerve. So on retina, the light, that is the light signal, gets converted into electrical signal. That electrical signal is carried by the optical nerve. After that, there is a brain. So brain interprets the whatever information received and we can see the object, correct? So there is a working of the eye. Okay, somebody was asking apparent depth. So apparent depth is nothing but, for example, let's suppose there is a water here, and let's suppose there is a bottom. There is a bottom of the lake or swimming pool. So there is a real depth. Correct? And because of the bending of light, what will happen? The light which is coming from the bottom, it will bend away from normal, correct? Something like this here. So this bottom will appear somewhere here. So this is the apparent depth. So there is a simple ratio of the real depth to the apparent depth. So real depth divided by apparent depth would be the refractive index. This is a refractive index of the water with respect to the air. This is a simple formula. So from here you get the apparent depth as R, which is the real depth, divided by N. Okay, very simple formula, but I don't think they will ask any question based on this. Okay, so now here the important part, it is not the structure of the eye that is important. What is important is the lens. Lens is important and the eye defects, that is important. So this is a convex lens. Because we have learned so much about the lens, so they will ask some questions regarding the lens, and it forms real and inverted. So can you see, this is a real and inverted image. Okay, so in this case, can you tell me, if let's say the object is like a moon, you are focusing the moon on the retina. The size of the eye, so I will just write here, size of eye is, let's say, 2.3 centimeter. So what will be the focal length of this lens? That is a question. Yes, squad killers, you have question, you have doubt, tell me. You understood my question? Object is at infinity. For example, moon. You want to focus the moon on the retina. The size of the eye is 2.3 centimeter. So now, can you tell me what is the focal length of this lens? What is the focal length? Yes, just directly shout the doubt. Just tell the doubt. I am reading most of the chat. What is science? Okay, that is a very good doubt, and it will take me one whole day to explain what is science. The focal length here, what will happen? All these light will be forming the image at the, so this will be the focus, correct? The retina will be the focus. So this is the focal length. If the size of the eye is 2.3 centimeter, approximately our focal length is 2.3 centimeter. Clear? Now the major thing here from this topic is the defects. There are two major defects, that is myopia and hypermetropia. Hypermetropia. Okay, so what is myopia? In myopia, the size of the eyeball is elongated. So there is an expansion here. Size of the eyeball is elongated. In hypermetropia, this is shortened. Size is compressed. So in myopia, what happens? The distance object at infinity, the image is formed before the retina. Here the object is at near point, that is this distance is 25 centimeter. If you place the object here, there is the object, so its image is forming behind the retina. So now how do you correct it? So here what we want the rays to diverge, correct? We want the image to go little further behind. So we want the rays to diverge. So what we do? We place a concave lens. So it will diverge the rays, and now these rays, they are focused on the retina. In this one, we want the rays to converge because the image is forming behind. We want them little earlier. We want them to converge much earlier, much quickly. So we want to place a lens which is a converging lens. So what it does, it starts to converge these rays, and then they are focused on the retina, correct? So in the myopia, what happens exactly? The far point is shifted much closer than the infinity in the myopia. In hypermetropia, what is happening? The near point has shifted away. There is a near point. Near point goes away or recedes away. In myopia, far points shifts closer. So in myopia, the objects which are very far, you cannot see them or they are blur. But this person can see the object which are near. In hypermetropia, the person cannot see the object which are near, but he can see the object which are very far away. So these are the major differences and how to correct them. Clear? Okay, so now the next topic, that is prism. So let's have one quick question from the prism. There is a question. I'll have some water. Read the question. Okay, there is a half question. There is a ray diagram. Study the following ray diagram and identify angle of incidence, angle of emergence and angle of deviation. So these are the four options. Okay, so is this a correct diagram first of all? What do you think? Prism. Okay, you are just spamming anyways. So is this a correct diagram? Yes, this is a correct diagram. So till now we were learning that the light always fall onto this face, correct? That was we were learning. But what is the point? Let's suppose if I have torch on this side, light will fall here. But if I just change the torch direction, So there is a torch here. So what will happen? Light will fall onto the other face. Correct? So now there is a normal here. So what will be this angle? This is the incident ray. So this is the angle of incidence. Correct? So light is going from air to glass. So it will bend towards the normal. So this is the our refracted ray. Correct? This is the second point of incidence. So there is again another normal. So now what will happen at this place? Light is going from glass to air. So it will bend away from normal. So there is our angle of emergence. So we want angle of incidence. So this P is the angle of incidence. This Y is angle of emergence. Now what is angle of deviation? So that is the angle between incident ray. This is the incident ray and this is which kind of ray? There is a incident ray and emergent ray. So this angle between these two is called as angle of deviation. So what is angle of deviation here? This is the incident ray, correct, this one, and this is the emergent ray. So angle between these two, it is this Z. So Z is our angle of deviation. So Z is angle of deviation. These are correct, this is not correct. Angle of incidence is P. So it is this P. So this is correct. And angle of emergence is Y. So this is the correct option. Okay? Easy? Great. So now let's go to the next question. Anything about presbyopia? Presbyopia is simple. If you know this one, if you know hypermetropia, then presbyopia is exactly similar to hypermetropia. There is nothing great. Just that the origin, why presbyopia happens, it is to people who are older than 45 roughly age, they get the presbyopia. But everything else is correct. I mean similar to hypermetropia, image is forming behind. So you have to use the convex lens to get the image on the retina. It's very easy now. Okay, there is a prism. So these are the different rays, incident ray, refracted ray, emergent ray, and the angle between incident and refracted is the angle of deviation. So make sure that you remember these equations. Sometimes they will ask you some question which is directly from one of these equations. What is the first equation? This angle of deviation delta. It is the sum of delta 1 and delta 2. Correct? Then the second equation, it says that this angle of deviation is this I1, I2, or one of them is angle of incidence, angle of emergence minus R1, R2. But what is R1 and R2? It is this angle of the prism. This is R1 and R2. So just substitute and you get the fourth equation. Okay. So derivation is not important. Don't worry about the derivation. Just remember these formula. Write it down somewhere in front of you. So you'll just remember. So we are going to learn all the formula from the physics today. Write down somewhere. Make a chart. Keep it in front of you. At least for until you have the exam. You'll learn everything. Okay. So now solve this. What is meant by dispersion of light? So there is a 2-mark question. There are 2 sub questions, 1 mark for each. 3 days for maths, 1 day for SST and 1 day for Hindi. Great. SST 10 days. Nice. Nice, nice. So which is your favorite subject? Which is the easiest and which is the most difficult out of all the different subjects? My favorite was maths. Maths was like easiest for me. Okay, so what is dispersion of light? So let's do that. This is a white light. When the white light falls onto the prism, this white light split into different colors. So these are the 7 different colors, the same colors that we see in the rainbow. This is called as dispersion of light. Okay, maths is hardest. Okay, all right. So which color deviates the least and one which deviates the most? So here when the light passes through the prism, red color deviates the least and violet color deviates the most. Okay, and why different colors deviate by different angles? So what is deviation? This is the our incident ray, correct? So there is an angle of deviation for red, there is an angle of deviation for violet. You see, the violet color has deviated the most. Okay, so now why different colors they deviate? Because the speed, do you know, speed of the light is directly proportional to wavelength, and these 7 colors they have different wavelength. Red, there is a red has the maximum wavelength which is around 700, and violet has the minimum wavelength which is around 400 or 350, that is the range. So because the violet color has the least wavelength, it will have the least speed, so it will take longer time for the violet to come out of the prism. That is the reason it will deviate the most. And the red one, because it has very larger wavelength, so larger speed or greater speed, so it will come quickly, it will come out of the prism very fast, very quickly, so it will deviate the least. Clear? So this is the dispersion of light. So now this is a rainbow. What happens in the rainbow? So there is a sunlight or white light. White lights fall onto the raindrop. So these raindrops, they act like a tiny prism. So now there is a dispersion, there is a refraction and dispersion happening at this point. Then there is an internal reflection and light is bending backwards, correct? And again there is a refraction. So these different colors they separate. So that is what happened in the rainbow. By the way, do you know what is critical angle and total internal reflection? I'll quickly tell you. So when the light goes from the denser medium, there is a denser medium, to the rarer medium. So let's suppose there is a source of light, there is a angle of incidence, there is an angle of refraction which is 90 degree. So if R, which is the angle of refraction 90 degree, then this is called as critical angle. Okay, and if the angle of incidence, so there is a medium, so there is another angle I, angle of incidence. So if this angle of incidence is greater than critical angle, what will happen? All of the light is reflected internally. Light will not go to the other medium. So that is called as total internal reflection. Total internal reflection, and exactly same thing happens in the rainbow formation through the water drops. Okay. Okay, let's solve this question. This is an assertion reason type question. Solve it. I'll read the chat. MCQ is easy when you eliminate options, correct. You guys are creative. Electricity में problem होती है. Okay, we'll go to electricity after this. Okay, 5 or 10 more minutes, then we'll start with electricity. Solve it. When you don't know answer, okay. Okay, let's solve this. So assertion is given as when the rainbow forms, light at the water drops, inner surface is internally reflected. That is the assertion. Is this correct or wrong? At this surface, this is the inner surface. This is the inner surface. So is the assertion correct or wrong? Internally reflected, that is a total internal reflection. This is correct. Assertion is true. Then reason, the critical angle is more than angle formed by the refracted ray and the normal to the drop surface. So is the reason correct? So do you know what is critical angle? Just now I told you critical angle is there is a surface, there is a normal, there is a critical angle C, and there is a refracted ray which is 90. So what is the reason? Critical angle is more than angle formed by the refracted ray and the normal to the drop surface. So which one is the refracted ray? This one is this is the refracted ray and this is the normal. So this is the angle. So let's suppose if this angle theta, this is the angle theta. So what is saying? Critical angle is more than this angle theta. Is this correct? No, this is not correct. If you want total internal reflection, for example here, if this is the angle theta, so this angle theta should be greater than the critical angle. So this reason is not correct. Okay. So which one is correct? A is true, R is false, that is option number C. Okay. Now the next topic from this chapter, that is atmospheric refraction. It is very easy, just a common sense. So there is earth has the atmosphere. If I choose two different points, let's suppose there is a point, I'll use different color. There is point A and let's suppose there is a point B. So at which point air is denser? Density of air is greater at A or at B? That is the question. What do you think? हिंदी और मराठी में से चूज करना होता है. Okay. So when you go near the surface of the earth, there's a vacuum here, right? Do you know? There's a vacuum. So from the vacuum, when you go near the surface of the earth, what happens? The density increases. This is from all the directions. So everywhere outside there is a vacuum. So the density is greater at A, not at B. So at A will have more dense atmosphere, a lot of gases near the surface. At B it is a low density. So if you know the refractive index of vacuum is 1 and the refractive index closer to the earth atmosphere is 1.0003. There is a very small change, but this distance is quite large, few hundred kilometers, and because of that what happens? The light coming from object, for example sun or some star, so there is a straight line from the star in the vacuum, but when it enters the earth's atmosphere there is a gradual bending of light due to gradual increase. So there is a gradual increase in the refractive index. Because of that there is a gradual bending of light, and due to this what happens? The sun or any other star which is near the horizon, it will appear shifted. This is the apparent position. This is the real or the actual position of the star or of the sun. So all of them will be shifted little bit upwards. Correct? So this is called as atmospheric refraction. So now stars near the horizon, they appear slightly higher than the actual position. So these things, they happen due to atmospheric refraction. Second one is advanced sunrise. So sunrise happened 2 minutes early and delayed sunset. Sunset was delayed by 2 minutes, correct, due to atmospheric refraction. Third one, apparent flattering of the sun's disk. So now why this happens? Let's suppose there are two rays coming from two surfaces. There is a bottom and there is a top, correct. Both of them, they fall onto the atmosphere. So now this bottom ray is coming from lower part. So it will bend, it will go through the more bending. The upper ray, it will bend less, correct. This top ray will bend less. The ray coming from the bottom surface will bend more, and because of that the sun's disk, it will appear distorted. That is called as apparent flattering of the sun's disk. All these things happen due to atmospheric refraction. Easy? Very simple, right? Okay, so now twinkling. You see some stars, they are twinkling. So why twinkling? So let's suppose there is a star here, there is a light coming from the star. Sometimes light will appear, it will come, reach to the observer. Sometimes this light go somewhere else, correct. When the light reaches to the observer, star will appear brighter. If the light goes somewhere else, star will appear dim. And that is the reason some stars or some object in the sky, they will appear they are having this twinkling effect. And what are those? These are all stars. Now there are some objects, you see here, some objects in the sky, they do not twinkle. And what are those? These are planets. So planets do not twinkle. And what is the reason for that? Why planets do not twinkle? Because planets are very close compared to all the other stars. Planets are much closer. So the star will look like there is a star, there is a point object, and if it is a planet, there is a extended source of light, correct. So now the light coming from the dot, it will sometimes be visible, sometimes it may not be visible. That is the reason the stars, they twinkle. Planets, because it is an extended source, all the light which is coming from the different points on the planet, they will average out. The variation will average out. So the planets do not twinkle. That is the twinkling of light. Yeah, it doesn't matter whether they have their own light or they don't have their own light. It is even the sun, if you don't try, but even the sun does not twinkle. Why it do not twinkle? Because it is the largest. It will have the disk, right? Sun's disk. So it is an extended source of light. So it does not twinkle. Okay, you can look at the sun in the evening sky. It will not twinkle. Or use a proper sunglasses and observe. Now the Tyndall effect. So what happens in the Tyndall effect? There is a light passing through certain medium. So you will see the path of the light. If it is a clear solution, light path not visible. This is a colloidal solution, so path of the light is visible. That is called as Tyndall effect. You observe the path of the light when the light passes through the colloidal solution, that is called as Tyndall effect. Clear? If let's say this room is very clean, perfectly clean room, can you observe the Tyndall effect? Answer is no. You won't be able to see any Tyndall effect, because to see the Tyndall effect you need suspended particles. Then only it is the path of the light would be visible. Clear? Now the last part from this chapter, that is scattering of light. You see here the light, single light photon, it splits into different colors and it spreads all over the place. That is called as scattering of light. So now solve this question. What factors determine the color of the scattered light? What are the factors? Tyndall effect doing in physics. Just having fun, just chilling. Okay, so now what are the factors which determine the scattering? So this scattering is determined by the particle size. If the particles are small, for example, these gases, nitrogen, oxygen, carbon dioxide molecules or water molecules, these are tiny particles. So we will have the scattering inversely proportional to lambda raised to 4. Lambda is the wavelength, correct? Wavelength would be larger for red. So lambda is large for red, orange, yellow, and it is small for blue, indigo and violet, these colors. So the blue, indigo, violet, these colors will be scattered the most by the tiny particles, and red, orange, yellow, they will be scattered the least by the tiny particles. But if the particle is large, what are the large particles? Water droplets which are present in the clouds, then dust particles which is present in the smoke, or yes, smoke, correct, or dust if there is a sand storm or something, then these are the large particles. They have large particles, so all the colors scatter, all colors scatter equally, and that is the reason they will get scattered equally. They will form different colors, then they recombine to form the white light. That is the reason the objects which look white in color, for example clouds or the milk, it is because of the large particles. And the object, for example sky, appears blue because we have nitrogen, oxygen, carbon dioxide, these molecules present in the atmosphere. The ocean, they look blue because of the water molecules. They scatter the blue light. And there is one more thing, the water molecules, they absorb red color. That is the reason the oceans are dark blue color. Clear? Great. So now the next topic, that is electricity. Any questions until now? Yes, tomorrow is going to be bio class, correct. Any questions, anyone? So now let's start with the electricity chapter. So what is there in electricity? Only the formula. Remember all the formula and you can solve all the questions. The first formula will tell you the current. I is a current, Q is a charge, T is time. Okay, I'll write the physical quantity and SI units. So physical quantity is current, SI unit is ampere. Physical quantity is charge, SI unit is coulombs. Physical quantity is the voltage. It is represented by V, and the SI unit is V, that is also volt. Then we have, what else we have? Resistance, SI unit is ohm. Okay. So what is this V? V is the potential difference between the 2 points. W, so physical quantities, it can be W or heat or energy. All of them will have the same SI unit, which is joules. J is for the joules. Okay, volt is equal to W by Q. What is W? It is the work done in moving a point charge or unit charge from one point to another point. What is R? This is called as Ohm's law. V divided by I, or the ratio of the V by I is constant. That constant is the resistance. What is this formula? Resistance is rho L divided by A. Rho is the resistivity, L is the length of the conductor, A is the area of the cross section. Correct? Now, the two important things which I have seen lot of questions on this ammeter and the voltmeter. Why do we use ammeter? To measure the current. So, I will just write down ammeter measures current, voltmeter it measures the voltage or the potential difference. Ammeter is placed in series, voltmeter in parallel, in series with the battery or in series with the resistance. Voltmeter is always in parallel with the resistor. Okay. Now, these are the current voltage or voltage current graph. So, for example, here you see the voltage current, there is a straight line. So, we can say the slope in this graph is nothing but change in the voltage. Change in voltage is nothing but potential difference. Correct? There is a potential difference V divided by change in current, that is I. So, slope is V divided by I, which is nothing but our resistance. So, when you plot voltage versus current graph, the slope is the resistance. But if you plot current versus voltage graph, so there is a current versus voltage. So, what is the slope here? So, slope is current, which is the y coordinate, divided by the voltage. So, that will be I divided by V is 1 by R. So, slope for this graph is 1 by R, or inverse of resistance. Here the slope is our resistance. Do you guys want 5-minute break? Okay, let's have 5-minute break. Even I am feel tired. 5-minute break. We'll come back quickly after this. I'll put the timer. Okay, how much you want? 5 minutes? Start. So, we'll come back after 5 minutes. Go have a loo break and come back. Even I need a break. There's so much light here. I'm having a headache. Just give me 5 minutes. Any one. केज बंद कर दो. हेलो, सही आवाज. Okay everyone, let's start. So here this is the direct application from the Ohm's law. What is Ohm's law? We know Ohm's law is V is equal to this is the Ohm's law, V is equal to IR. So this is a direct application from the Ohm's law. We can either plot voltage versus current graph or current versus voltage graph. If you plot voltage versus current, the slope is the resistance. When you plot current versus voltage, slope is inverse of the resistance. Okay, so now the most important topic from this chapter, it is a series and parallel combination of resistances. You can either arrange the resistors in series. So in series what happens? The same current flows. There is the same current which is flowing through all the resistances, same current I, right? That is a series. When you have parallel, it is the same voltage because they have the common terminal. One of them is positive terminal, another is negative terminal. Positive terminal means higher potential, negative terminal means lower potential. So the potential difference is constant. So when you have potential difference constant, there is a parallel combination. Okay. Now the equivalent resistance for the series combination, this RS is nothing but equivalent resistance for the series combination. It is just addition of R1, R2 and R3. But what is the equivalent resistance for the parallel combination? So this Rp is the equivalent resistance for the parallel combination. Take the inverse of all these resistances, add them. So that will give you the inverse of the equivalent resistance. So now do you know some properties about this series and parallel? So Rs, which is the equivalent resistance, always greater than R1, R2, R3, all of them, and Rp will always be less than R1 or R2 or R3. So which is more practical, series or parallel? Parallel combination is more practical. In our houses, we use parallel combination. Why do we use parallel? Because each of them can draw required amount of current and the voltage is maintained constant. That is, these two are very important. For example, you don't want to place AC in series with the, for example, tube or bulb. The bulb will explode. Okay, we don't want so much current passing through the bulb. AC is a heavy device, or for example electric iron, that is a heavy device. So we want them in parallel. We don't want them to put in series. So parallel has lot of practical applications. Yes, correct. Now solve this question. Okay, there is a paragraph, there is a, these type of questions will come in your exam either for 3 mark, 4 mark and 5 mark. Definitely one will come. I have a strong feeling the section E might come from this chapter. Strong feeling. So these two chapters, electricity and magnetism, very important. पैरेलल में करंट इक्वल नहीं होता है खुशाल. इन पैरेलल द करंट स्प्लिट्स, राइट? दिस I1, I2 and I3, they are different. So current is not equal. In series it is the same current. सीरीज में करंट इक्वल होता है, पैरेलल में नहीं होता है ना. यस, वोल्टेज इक्वल होता है, करेक्ट. Great. So now read this paragraph, and based on this paragraph and this diagram, we are going to solve some questions. So this is like a competency based or case study type questions. You will, once you learn the questions, you will find that okay, these are not that difficult. We have a feeling okay, there is a case study based, so must be difficult, but that is not like really difficult. So read the following paragraph. What is the paragraph? Connect a nichrome wire length L. So there is a length L of the nichrome wire. There is a nichrome wire here placed between points X and Y, and provided there is a battery which is providing the voltage. There is this ammeter. It will measure the current which is passing through it. Okay. So record the ammeter will measure the current values. So now based on this was actually the 5-mark question, but I have removed couple of questions. So this would be either, maybe there would be 2 or 3 questions only. So what change ammeter reading is seen? Okay, so now the same thickness but twice the length. You saw that nichrome wire, this nichrome wire. So the resistance, okay, I have this diagram here, this nichrome wire. So resistance of the nichrome wire will be given as resistivity of this nichrome multiplied by length divided by area. Correct? Let's suppose the initial resistance is R1, which will be rho L by A, the earlier length and area. Now same thickness, so the area is constant but length is doubled. You double the length, so resistance R2 will be rho, length is double, 2 times L divided by area. So this will be 2 times R1. So resistance has doubled. Resistance of the nichrome wire is doubled. So what will happen to the reading of the ammeter? So it will measure the current. This voltage is constant, voltage is fixed. So what should be the reading? Will it measure higher current, lower current, or same current? Tell me. So now here we know Ohm's law, which is voltage is constant. So Ohm's law says resistance is voltage divided by current. Voltage is constant, so current is inversely proportional to the resistance. If you increase the resistance, you see from here to here resistance has increased. Resistance increased. So what will happen to the current? Current will decrease. Current which is flowing through the circuit will decrease. So ammeter reading will be half, will be double, will increase 3 times, or it will become 3/4. So what will happen to the value of current? Resistance you increase twice. So ammeter value, that is the current value, will be half. Okay. So that is the correct option. Ammeter reading will be half of the original value. Yes, we'll do the Menti from, I think from Tuesday onwards. Tuesday, then Wednesday, Thursday. 3 days, 3 Mentis. Okay. All right. Now the second question from the same paragraph, same diagram. So 2 resistors of value 3 ohms and 6 ohms are connected in series to the circuit. For example, here if you connect 2 resistances, okay, there is a 3 ohm and there is 6 ohms. How will the current passing through the 2 resistors vary? So whatever current is passing through it, how will it vary? Can you tell me? Current will remain the same, current will increase 2 times, current will decrease 2 times, none of the above. Current will increase 2 times. Okay, nice, Vishnu. And that is wrong. So tell me what will happen? Sumit, what do you think? 1 hoga? You think it is first one? Again, read the question. The 2 resistors are connected in series. These are the 2 resistors connected in series. So the current passing through the 2 resistors. So current which is passing through these resistors, will it be same or will it be different? It is going to be same current, right? Current passing through these 2 resistors, it is going to be same. Okay? They are not in parallel, they are in series, so current should be same. Now the next one, okay, only these 2 questions, easy for you. Next topic, that is a Joule's law of heating. So what is Joule's law? So Joule was a scientist who discovered the heating effect of current. What he said, the heat produced directly proportional to the square of the current, directly proportional to the resistance, and directly proportional to the time. So he got this equation, H is equal to I square RT. That is the heat produced in a wire, in a resistor, when the current I and time T is this much time, current is passing through it. Okay, so now there is a heat. But do you know what is electric power? So we know power is equal to heat divided by time. What is heat? I square RT. I'll just substitute it here. So it is I square RT divided by time. So this time will get cancelled. So it is I square R. So that is the first equation. Power is I square R. So now do you remember Ohm's law? Ohm's law says that R is equal to V by I. Substitute it in this equation. So we get power is equal to, instead of R, I am substituting V by I. So this is I square multiplied by V by I. So one current will get cancelled out, that is V times I. So that is the second equation for the power. Power is I square R, it is equal to V times I. Now you can again substitute for, let's suppose take this I is V divided by R, substitute this in this equation, what you will get? Power is equal to V multiplied by, instead of I am substituting V by R. So this multiplied by V by R, that would be V square divided by R. So these are the 3 different equations for the power. V square by R, V times I, and I square R. Okay? So that is the Joule's law of heating and electric power. Any questions, anyone? Okay, so now the next topic, that is magnetic effect of electric current. And let's see what we have. First question, which of the following is incorrect regarding the magnetic lines of the field or magnetic field lines? So there are 4 options. You want to tell me which one is incorrect. Is it the first one, direction of the magnetic field? Okay, solve it, tell me the answer. Okay, Sumit, thanks. Okay, let's read all the options. The direction of magnetic field at a point is taken as the direction in which north pole of the magnetic compass needle points. Is this correct? You remember bar magnet? Okay, I'll do it here. So there is a bar magnet, right? These are the magnetic field lines. When you bring a, let's suppose there is a bar magnet, there is a north and south. If I place a compass needle at different locations around this bar magnet, So it will point something like this. There is a north and south. Here it will point like this. There is a north and south. Correct? So what it is showing? It is showing that the magnetic field is coming out. That is the arrow of this needle. So this first statement, this one is correct. The north pole of the compass needle will point to the direction of the magnetic field. Second one, magnetic field lines are closed. So here you look at the magnetic field lines. Do they look like closed? In this diagram that does not appear, but how it should be? The magnetic field lines, they go out from the north, go inside the south, and inside the magnet they go from south to north, right? So now can you see the magnetic field lines? They are closed curves. That is correct. How about option number C? If the magnetic field lines are parallel and equidistant, they represent zero field strength. For example, if the magnetic field lines are parallel and equidistant, does that mean it is a zero field? No. That means there is a uniform magnetic field. So this is wrong. And how about the last one? The relative strength of the magnetic field is shown by the degree of closeness of the field lines. So let's look at this figure. So here the region near the north pole or the south pole, the magnetic field lines are close, so they are dense. So the magnetic field strength is stronger near the poles. But when you go away from the pole, the region which is away from the pole, the field lines are they are not that dense. So magnetic field strength is lower away from the poles. So this statement here, okay, is not working. This last statement, this is correct. So only incorrect statement is the option number C. Clear? Okay, let's go to the next topic, that is magnetic field. So what is magnetic field? There is a vector quantity. What is the meaning of vector? It means it has magnitude and direction. Magnetic field will have magnitude, that is the strength of the magnetic field, and direction. So there is a bar magnet and these are the magnetic field lines. How do you know at which location the magnetic field is stronger? So magnetic field strength is proportional to the density of field lines. Is it written? Yeah, it is. Magnitude is density of the field lines. So near the poles density is greater, so magnetic field is stronger near the poles. Away from the poles it is weaker. So that is the magnitude. Direction, so at any point if you draw a tangent at any point, that will give you the direction of the magnetic field. Tangent at any point of the magnetic field line will give you the direction of the magnetic field. Clear? Okay, now let's go to the next point, that is right hand thumb rule. What is right hand thumb rule? Imagine that this is a conductor. So current is going from bottom to top in the vertical direction. I am holding it in my right hand, so my thumb will tell the direction of current, and the fingers which are curling around, they will tell the direction of magnetic field. There is the I, current going up, there is a magnetic field which is curling around. Correct? So now when you have a straight conductor, this is a straight conductor from A to B. Correct? So these are the magnetic field lines. They are concentric circles. Can you see? These are concentric circles. That means all of them have exactly same center and all of them are circular. That is the meaning of concentric circles. Now here we use a compass needle. This is a compass needle. So why do we use compass needle? Because let's suppose there is a compass needle. When you bring a magnet near the compass needle, so there is a magnet, if you bring near the compass needle, what will happen? This compass needle, it will rotate. So this is the earlier north-south direction. Because of the magnet, it will rotate. So there is a north, so this will be the south and this is the north of the compass needle. So by what angle this needle has rotated? This is the angle theta. This angle theta is called as deflection. Okay, this is the deflection in the compass needle. By what angle it is rotated? So theta is equal to 0 degree. That means minimum deflection, and theta is equal to 90 degree. That is the maximum deflection. Okay. So deflection, you measure, you change the current which is passing through this conductor AB and measure the deflection. What did people observe? The deflection is directly proportional to the current. When you increase the current, deflection increase. The second one, deflection is inversely proportional to distance. This is the distance between the conductor and the compass needle. If you bring the compass needle far from the conductor, then deflection will, when you increase the D, deflection will decrease. That is the inverse relationship. But what is exactly deflection? So this deflection in the compass needle will tell you the strength of the magnetic field. So magnetic field strength directly proportional to current and inversely proportional to the distance from the conductor to the compass needle. Clear? Now we have a circular loop. So in the circular loop, there is a direction of the current. There is a direction of current flowing through the circular loop. At all the points, you can use the right hand thumb rule, and at all these points, it will show the magnetic field is pointing in the same direction. So all of these points will add up the magnetic field inside this loop. If you take a cross section, let's just choose two different points. Let's suppose there is a point A and there is point B. So at different points, these magnetic field lines, they look like a concentric circles. Yes, but because there is a complete circle, because of the complete circular loop, now the magnetic field lines look something like this. They are very dense near the conductor. Near this circular conductor, magnetic field lines are dense. When you go away from the conductor, magnetic field lines are less denser. And at the center, look at this line, which is a straight line. So at the center, magnetic field line or arc will become a straight line. So these are properties of the magnetic field lines due to circular loop. Now, if we have multiple such loops, that is, okay, we have a question now. So draw the pattern of magnetic field lines of current carrying solenoid and a bar magnet. So how do we solve this? So when we have multiple such loops, circular loops, and you make sure the current is passing in the same direction through all the different loops, then what will happen? The magnetic field due to one loop and due to another loop, they will get added up. So inside this region, you will get a magnetic field which is uniform. So if you compare the solenoid, so this is a solenoid, okay, the magnetic field lines will look something like this. inside they are uniform and outside they go something like this. These are the magnetic field lines from the solenoid. And how about bar magnet? Do you remember bar magnet? It is north and south. These are the magnetic field lines of a bar magnet. They look very similar. Inside the bar magnet, it is something like this. The magnetic field lines are very similar for the solenoid and the bar magnet. But what is the difference? So they have asked two differences between these two. First difference, the bar magnet is a permanent magnet. So the magnetic field lines are always on. Magnetic field is always on. Here, if you switch off the current, so no current, what will it do? No magnetic field. When you switch off the current passing through this solenoid, then it will not produce any magnetic field. This is the first difference. Second difference, the strength of the magnetic field you can change. How can you change? For this, increase the current. When you increase the current, magnetic field will increase. So magnetic field is proportional to the current and is proportional to the number of turns, a number of loops. But for the bar magnet, magnetic field you cannot change. Whatever magnetic field is available, you can have only that. You cannot increase, you cannot decrease. Third difference, this is easy to demagnetize. Demagnetize means right now it has the magnetic field. You switch off the current, now it is no more magnetic. But here, to demagnetize the bar magnet, it's very difficult. You have to heat it up to a very high temperature. Then only you can demagnetize it. Okay, so these are the basic differences between solenoid and the bar magnet. There is a solenoid, you can have some core. There is a soft iron core which is placed inside the solenoid just to multiply the magnitude or the strength of the magnetic field by large amount. Okay. Now the force, direction of the force on the current carrying loop. For example, we use the left hand rule. So here remember the rule FBI. Thumb will tell you the force, first finger magnetic field, second finger current, FBI. You can use like FBI, which is Federal Bureau of Investigation, or father, then mother, child. F for the father, M, that is the magnetic field for mother, C, which is current for the child, father, mother, child. You can use whichever way you want to remember. So now the direction of the force depend on direction of the current as well as direction of the magnetic field. That is why we can use this left hand rule, Fleming's left hand rule. If the angle between the magnetic field and current is 90, then the force would be maximum. But if the angle is 0, then the force would be 0. If the angle is 0, that means the magnetic field and current, they are parallel. If there is a magnetic field and this is a current, so they are parallel. So there is no force. So force would be 0. Okay. In this case, you cannot use left hand rule, Fleming's left hand rule. Okay. So now last topic, that is alternating current. And I have seen lot of sample papers, there is at least 1 or 2 questions from this topic, that is alternating current. So what is alternating current? You see here there is a voltage and time. When you plot the voltage across time, for the alternating current, voltage keeps on fluctuating. For the direct current, the voltage is constant. Direct current, constant voltage, alternating current, voltage fluctuates. Then the direct current it is unidirectional. there is a proper direction for the current. In alternating current, you see here, this current fluctuates, the direction changes, so it will depend on the frequency of the AC, right? In DC, the current is uniform, unidirectional. If let's say the frequency is 1 Hertz, frequency of the AC is 1 Hertz, that means it is going in one direction and coming back. This is a one oscillation in 1 second. So in 1 second it changes the direction 2 times. If let's say the frequency is 50 Hertz, so in that case the current will change the direction 50 multiplied by 2, that is 100 times. Okay, so this frequency matters a lot. In India we use 50 Hertz, in other countries they use some different Hertz, let's say 60 Hertz in different parts of the world. Now we have the 3 kinds of wire. The black one is a neutral, green is the earth wire, red is live wire. Red is like a hot, so that is a live wire. Black is like neutral, not that harmful, and earth, which is a green, which is safe. So this was the old convention. Nowadays they use this kind of convention, which is they mostly won't ask, is difficult to remember, but generally we currently they have these color combination. So these are the 3-pin plug which you see in our houses. The live wire has a potential of 220 volts, neutral wire 0 volt, earth wire 0 volt. So live wire is always on. You cannot switch it off, the live wire. When you switch off the live wire, that means there is no electricity. Sometimes you say, right, there is no electricity or current chala gaya. That means the potential of the live wire is 0 volt. So that is the meaning. If you touch the live wire, you will get the electric shock. If you touch the neutral wire or the ground wire, nothing will happen. They are already at 0 volt. So they are like a safe. But sometimes what can happen, there is a wiring which is not so good. So in that case, if the live wire come in contact with neutral wire, there should be, ideally there should be some resistance between these two. There is a resistance R. There is our electrical devices. So the current which is flowing through it, you can write it as current is voltage divided by resistance. What is the potential difference between live and neutral wire? Potential difference is 220 volts divided by the resistance. But sometimes what can happen, there is a short. So this resistance is not there. So if the resistance is not there, these wires they get short. That means the resistance is almost equal to 0. So if the resistance is 0, so just substitute it here, it is 220 divided by 0, so that will be infinity. So that means large amount of current will flow from the live wire to the neutral wire. This is called as short circuit. Okay. Now there is our domestic circuit. Here the important things are, there is a live wire, there is a fuse. You should place the fuse always in the live wire. Then we have the electricity meter. It tracks the amount of energy consumed. Energy consumed. It does not track the current. It tracks the amount of energy we have used. Then we have the electricity board. So it distributes the current to different parts of the house. For example, this part there is a AC or heater, so it might require large amount of current. There is a bulb or fan, so might require low amount of current, right? There is a distribution circuit or distribution board. Now the potential difference, you see all of them, they are in parallel. This is a parallel combination. All of them are maintained at 220 volt, which is the potential difference between live wire and the neutral wire. Okay, and there is a third wire. This is the earth wire. So why do we need this? Sometimes what happen, the live wire might come in contact with the metal part of a object. Let's suppose there is a fridge. So live wire may come in contact with the metal part of the fridge. So there is a extra charges present on that metal part. So if you touch the fridge, you will get the electric shock, and to avoid that, we use the earth wire. So this earth wire is connected to all the metallic parts and is grounded. So it will go below the earth. So whatever extra charge is present is taken to the earth. So now all the devices are safe to use in our house. That is called as earthing or grounding. Okay, so now I think this is the last question. There is a PQ, which is a current carrying conductor. This is a straight wire. Okay, what direction does it produce the magnetic field at point R and S? So there is a point R, there is point S. At these 2 points, what is the direction of the magnetic field? So how do you know direction? We use the right hand thumb rule. Hold this conductor in your right hand. So from R is going, the magnetic field is going into the page, and at point S, now these magnetic field lines are coming out of the page. So here we have out of the page magnetic field lines. That is the answer for the first one. Second one, where will be the magnetic field strength greater? So what is given? R1 is greater than R2. So there is R1 is greater than R2, but do you know magnetic field is inversely proportional to the distance. So if you increase the distance, magnetic field will be lower. So at point R1, magnetic field strength is lower. So magnetic field at point R is lower than magnetic field at point this point S. Okay, this is the answer for the second one. Third, how would the magnetic field's direction change if the polarity of the battery attached to the wire interchanged? So now let's suppose this is the wire. What wire was it? QP. This is Q and this point P. So there is a battery attached to it. So current direction was going up. So battery would be something like this. So now the question is saying you reverse the battery. So instead of this, if I reverse the battery, so battery is now like this. So what will happen? Current direction will reverse. So the direction of current here would be going down. There is a current direction, right? Earlier current was going up. I am still using the right hand rule. Now the current direction is going down. So now, okay, what would the magnetic field's direction change? So when you change the direction of current, what will happen to the magnetic field direction? At this point R, now you look at the fingers, they are coming out. So this will come out, the magnetic field lines coming out. Here they go into the page. So when you reverse the current, the magnetic field direction will also get reversed. So that is the answer for the last one. Clear everyone? Okay, so that's it for today. Thank you so much everyone. Bye bye, enjoy, have fun.